Okay, this is notes 8.2 day 1. Pre-calc section 8.2 is ellipses. You'll be able to understand geometry of ellipses and their key features, write equations, and translate them. We're doing that in the first four examples today. And then tomorrow we'll talk about applications of ellipses. Okay. As we go through with taking those notes in that blanked out spot. An ellipse is a set of all points in a plane whose distances from two fixed points in the plane have a constant sum. The fixed points are the foci, plural for focus, of the ellipse. The line through the foci is the focal axis. Okay. The point on the focal axis midway between the foci is the center. The points where the ellipse intersects its axis are the vertices of the ellipse. So we're talking about this being our focal axis. We call that in our equations the major axis, okay? That major axis will have an equation of 2a, okay? You'll have something called a semi-major axis length. Let's talk about our area formulas. You remember the semi-perimeter? When we use Heron's formula with the square root of s, the quantity a s minus a times the quantity b minus s minus b times the quantity c s minus c to find the area of a triangle. S was the semi-perimeter. You took the perimeter and you took half of it. When we're talking about the semi-major axis and the semi-minor axis, it's just the major axis cut in half, the minor axis cut in half, okay? So keep that in mind, that connection with previous vocabulary that we work with. Okay, the center, okay, you'll have a center, and as we start translating it about, that vertex, the HK, is the center of an ellipse. And then we have our focus connection and what's going on with how we get A, how we get B, knowing about C, the distance from the center to the focus. Okay, now this distance, D1, D2, these are constant distances, and any place along here, D1 and D2, add up to the same number. So the distance from one focus to the ellipse to the other focus, when you add those together, will always be the same constant, okay, in the same ellipse. Now, I've placed some stuff in this page that's different than the notes that you currently have, okay? And I kind of color-coded it, but the first thing I want you to realize before I get to this, I want to talk about the horizontal the focal major axis, okay? Pay attention to little things. Do you see a squared and b squared here? I've got x squared over a squared plus y squared over b squared. Check out y squared over a squared, x squared over b squared. This could be really confusing unless you realize that in an ellipse, A is always bigger than B. And A determines your major axis location, whether it's a horizontal or a vertical. And here's how you know. When it's a horizontal axis, I consider A with X. That determines that's this horizontal. My x squared, the largest number, A, is with X. When I'm talking about the vertical axis, the largest number is with Y. Okay, the y-axis is up and down. Okay, so it's going to look like this if I'm talking about the y-axis being up and down with the major axis. It's going to look like this, left and right, because the x-axis is the major axis, because x is with A. A, the larger of the two values underneath here. Okay. Now, talking about the length of the major axis. A helps us determine that major axis, and the major axis is the one that makes it elongates our ellipse. It makes it look more like a football. Okay. So A is bigger than B all the time, and when the bigger number's with X, it's a horizontal. When the bigger number was with Y, it's vertical. Careful. Notice how I wrote this. X squared over b squared plus y squared over a squared. Because generally you'll see x squared over a number plus b squared over a number. You've got to pay attention to which number, the square root of whatever the denominator is bigger than the other, okay? Because that'll help determine the orientation of your ellipse. It's dangerous because you get in this, you swing, oh, I got to do this, 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 and then you just put it on the graph the wrong way, okay? Now, major axis length. A helps me determine how long my major axis is because A is the distance from the center of my ellipse to the vertex, okay, on the major axis. So A is this distance going across right through there. That's my A distance. 2A determines the entire length of the major axis. B is the distance from the center to the minor axis vertex and on both sides. 2B is the minor axis. Remember, they'll talk about A and B as being the semi-major and semi-minor axes. Okay, that's semi, meaning they've cut it in half. Okay. Now, one other relationship that seems confusing. A squared equals C squared plus B squared. Because, well, Pythagorean theorem is A squared plus B squared equals C squared. What's the deal? We're talking about the relationship of the major axis, okay, to the minor axis and foci location, okay? So now, if I take my minor axis endpoint and I have my hypotenuse being A, my major axis length, I can find my foci length, C, okay, the length from the center to my focus of my ellipse using this relationship. So once you have two of those values, you can find the third. And that'll be always the case with the information provided in your problem if you're asked to sketch the graph or find its equation in standard form. Okay, and the equation in standard form is this: y squared over a squared plus x squared over b squared equal 1 for vertical, and x squared over a squared plus y squared over b squared equal 1 for the horizontal, right? Now, I've got some folks going, oh, it's a lot of things to memorize. Again, chunk the things you learn. Notice the things that are related to each other, and you have to memorize less, but no more, okay? Now, that talks about the ellipses being centered at the origin with the foci. Okay, we've got it set. Chord, major axis, minor axis, semi-major axis, and semi-minor axis. Please notice that statement about when we put in that semi, they're just really taking the major and minor axes lengths and cutting them in half. The vocabulary that we're experiencing in Chapter 8 really makes this feel more like it's a geometry class than anything else because of the shapes, because of the conics. To me, as I go through, because every day in geometry, I'm always going through new material with new vocabulary. So just reminding yourself as you go, just keep that in mind, is refresh your vocabulary by daily rereadings of what we're doing. This is a cheat sheet of what I just talked about, okay? Standard equation, and I have A is with X when A, remember, is greater than B. I will kind of put a little note that A is with X. That means it's going to be a horizontal major axis. Or I'll say A is with Y. That'll be a vertical major axis that I'm dealing with. But when I'm talking about A is with X, when I'm talking about the focal axis, we're talking about, okay, we knew it would be x-axis, especially when it's 0, 0. But check out where the foci is located. It's with X. Check out where the vertices located. A is with X. Okay, as I go through, these are the major two things that when I'm talking about the largest value in that equation being with X, everything's in the X value for my coordinates. Okay. When I'm talking about A being with Y, where the largest value, A squared, A, is with the Y value, what happens is everything goes with the Y side. Foci is about the Y, the vertices about the Y, okay? And this relationship extends itself when we start translating it about the axis with H and K. And again, the Pythagorean theorem, still, it's a huge relationship, but know why. That A is the largest value, and B, the minor axis, and C, the foci location, are there. If we find those squares, we can find A squared as well. Now let's use this as a equation. First, notice, I got 4x squared plus 9y squared equal 36. My first need here is put it in standard form. So I've got to divide all the way through by 36. How is it decided? 4 times 9 is 36. I have to have x squared and y squared alone with no coefficients on top, but divided by something on the bottom, my a squared and my b squared. But I also have to have a 1 on that right side. So when I divide by 36, I've got x squared 9 plus y squared 4 equals 1. Now I can break it down. A is my largest number, right? A happens to be with x in this problem because x squared is over 3 squared plus y squared is over 2 squared. So right now I know some information. First of all, I've got my semi-major axis length. Okay, by the way, that's my A value, is equal to 3. My semi-minor axis length, B, is equal to 2. Well, since A squared is equal to B squared plus C squared, I now can go 3 squared is equal to 2 squared plus C squared. And I got 9 is equal to 4 plus C squared, so I know C squared is the square root of 5. Or I should say C is the square root of 5, as I solve for that relationship. Okay? Completely from my semi-major axis length and my semi-minor axis length. Okay? Now, find the vertices and the foci. Vertices and foci. Our center is at 0, 0. Okay? So I got a center at 0, 0. My vertices. My vertices are all about the major axis. Okay? It's not about the minor axis. My vertices are found in my major axis. And because my A is with X, keep in mind that's A is with X, and how do I know that? That's the biggest number. A is with X, so it's going to be horizontal. Okay? So when I pull out my foci, if you look up, that's plus or minus C, 0, because it's with A. Okay? And I use my values of A and B to help me find my C value, my foci, distance from 0, 0. Okay? So now I've got that, and I can list it as this, which just means that I've got a point at negative square root of 5, 0, and a point at the square root of 5, 0. Now when you graph this, I know the square root of 5 is between 2 and 3. It's closer to 2 than it is to 3, right? Because the square root of 4 is 2. Square root of 9 is 3. So it should be closer to 2 than it is to 3 when I graph it quickly. Your calculator, if you graph it on there, it won't show your foci. Okay, it'll just show the ellipse. And we'll talk about graphing that in a second. Okay. Now we are asked to find the vertices and the foci. Vertices. We know that the vertice, because remember, X is, A is with X and not Y. Okay, my vertex, general form, is plus or minus A, 0. Okay, when we have 0, 0 as our center. So I know already that A is 3. Okay, I found that right here. Used it in a couple different spots. So my vertex should be negative 3, 0 and 3, 0. Questions about where I'm finding my values? And I listed what the foci is, what my vertex is, and everything else. Yeah, Mr. Foss.
So if the center wasn't 0, 0, would you still do the same thing?
Yeah, I would. It would be actually H plus or minus A and K as a center.
Okay.
Because I would look at my center, and A would go positive, negative from that center.
Okay.
Okay, so whatever I have as a center, if it's my axis is the x-axis, I'd move it up, and I'd still look at it as a horizontal axis, as my ellipse axis, and then I'd go plus or minus A
Okay.
for
So
that.
if you had two, two is like your center, you just do 2 plus or minus A.
You got it. Okay, 2 plus A, 2 minus A, and that's where our points would be. Okay.
But you leave that 0, 0.
Well, keep in mind that would be K then.
So
At that
just
point.
be 2.
Yeah, that would become K. All right. So let's go back to just getting this graphed. And so we have our major axis, the endpoints of our major axis set up. -3, 1, 2, 3, and +3, 1, 2, 3. Keep in mind, we had our foci, and it was a little bit more than 2 for our foci on both sides. We had our center as we go, that's 0, 0. And what's significant about that is we have a minor axis. Our minor axis value is 2. And we go from our center up to and down to. And now we get to take our ellipse and draw it in. Okay. So I have my foci posted, my center. I know what my major axis endpoints are because they're the vertices. And I know my minor axis. Minor axis is determined by B. 2B is the length of my minor axis. And I got sloppy there. I should say B is my semi-minor axis, half the minor axis. And A is the semi-major axis. It's half the major axis as I do this. You're all right with those? Okay, a lot of jargon, right? But once you get them focused on making sure you know the difference and how they're connected, it becomes easier. Yeah?
So how did you know how tall to be?
From my center, my B value determined right here, and let me get a different value so as I fumble, my B value, okay, is 2. And remember, that's the semi-minor axis, which is just half the length of the minor axis. So I know this whole axis here is 4 based on that B value. And I also know from my A value that that whole axis is going to be 6 as I go through. And they'll even give me problems specifically tailored for that. They'll give me the, hey, major axis this, the minor axis is this, or they'll tell me the semi-major or the semi-minor, and they'll expect me to know what information is provided and what I got to do with it, just based on vocabulary. Okay. Any other questions? It's good questions, guys. Okay. Now, we were asked to do the vertices, the foci, and then graph the ellipse. Okay, so we got those things going. In this next one, finding the equation and graphing an ellipse. So we're going to take the information, we're going to put it in the standard form of the equation where I have 0, 0 as my center. Okay, I already know that that's going to be right there. So remember, on this one, it's still 0, 0. And they say find the equation of ellipse with the foci at -3 and 3. Right now, I know C is 3. With the foci provided. Okay, you're all right with how I picked up on that? I also know that A is with Y because the foci is in the Y position. You see that one too. Okay, so it's going to be a vertical axis whose minor axis is length 4. The minor axis length 4 means B is 2 because half of that. Okay, and just right off there, we kind of rattled through the information we know, but I'll write it down right now. Okay, so since the foci is 0 plus or minus 3, that's provided, and that's my foci, I already know that C is 3. Since I have a minor axis, not a semi-minor, minor axis, length of 4, that's the same as B, 2 times B, so B must therefore be 2. Because of the relationship of A squared is equal to B squared plus C squared, I now can find my major axis length, or at least my semi-major axis length, and then double it to get my major axis length by plugging in 2 squared plus 3 squared for my A squared. So I got 4 plus 9 is 13. A is equal to the square root of 13. Okay. Now, it's the principal square root as I go through, it's positive as I'm talking about it right now. I have a major axis of the square root of 13. Okay, as I go through. Again, as I step through, I know the square root of 13 is between 3 and 4. Okay, I can pop it in my calculator, but as I'm graphing on this, it's going to be an estimate, right, as I go through. So now I know my vertices on the end, but you got to keep in mind, A is with Y. A is with Y as I go through. That's an important piece. And how do I know? Because right here, my foci is with Y. So my A is with Y as well. So I know already that I have Y squared, square root of 13, squared, plus X squared, with my B being 2 squared equal 1. That's my general form of the equation after I've taken my foci and my minor axis and I found my A. So since A is with Y, and I got that set, and I can put it in as we go, so you guys see a little bit better. So I got Y squared over 13, X squared over 4 is equal to 1. Okay, when I finally get it set up. So that's my equation in standard form as we go through. Questions about how I found the equation, how I found A, how I determined what foci is, or how I determined whether it was with Y or with X. Okay, now since it's with Y, we got to graph this thing. B's 2. Okay, so B's 2. A is the square root of 13, and that's more than 3, less than 4. Okay, more than 3, less than 4, 1, 2, 3, 1, 2, 3. Okay, so my graph should look something like that. Looks like an alien face, okay? So you can make fun of mine or make fun of yours as well. Maybe we'll put some eyes in there, okay? This graph came from Area 51. That's where it's from. But let's double check, make sure we found everything we were supposed to. Find an equation, found it, whose minor axis is length 4. Sketch the ellipse and support your sketch with a grapher. Now, here's the thing about supporting with a grapher. An ellipse is not a function, right? Because it fails the vertical line test. And it's also not one-to-one because it also fails the horizontal line test. We have to make it work for us in our grapher. So if I'm going to put it on in the equation in a graph, I've got this situation, and I'm going to get to this situation quite quickly. Okay, multiply by 13 and take the square root. You okay with how I did it? Manipulating, flipping things around? I have to, in my graphing calculator, do y1, y2, (13) minus x squared over 4, and then the opposite y2. And you know what's really cool about your graphing calculator? If you've got this all entered and you don't want to like labor through, done. It'll take that and graph it. So I already got it as a variable. I'm just taking the opposite of whatever was in there. And that's what that would be. So it goes quicker. Okay, does that make sense? So graphing in my GC, that's what I'd have to do to check my work. And again, I could trace around and find it, but unless I put in the major axis, I won't get the exact point from my graphing calculator. I can do the intersection using that major axis and a horizontal line. Okay, and that's only when it's with X. I couldn't do it when it's with Y because I won't be able to graph a vertical line in my graphing calculator. Are we doing okay so far? Now, the translations part, the H and K, everything's the same except the center is no longer 0, 0. Okay, the center is HK. All the other stuff still works. When an ellipse with center 0, 0 is translated horizontally by h units and vertically by k units, the center of the ellipse moves from 0, 0 to hk. Such a translation does not change the length of the major or minor axis or the Pythagorean relationship. So you just got to make sure you make the adjustment to hk. And realize that when I did the plus or minus c and the plus or minus a, when it was with x, plus or minus c is plus or h plus or minus c instead of just plus or minus c. And a is h plus or minus a. So I have two different points from that. And when it's with y, notice the difference. With x, it's in the x position. With y, hey, I'm plus or minus k. That makes sense because it's with the y. But if you chunk them together like that as you're thinking, okay, it makes it easier to make the connection. And to be honest, I would familiarize myself more with the HK version of an ellipse than the 0, 0 version, because if HK or 0, 0, it takes over. Okay, so I wouldn't look at it as, well, I got all this stuff to keep in mind. I would just make sure I knew that, okay, and was very, very clear about it. But it's the same stuff that we just did, except my center is now HK. Any questions about the connection with them? And we're still moving it around the axis the way we did everything with our parent functions at the beginning of the year as well. Okay, so I won't labor like I did on the first picture because it's very similar. We're still talking major axis, we're still talking minor axis. It's just that our center is now HK. Okay, to graph or write an equation for an ellipse from given features, sketch and label what you're given, locate and plot the center if not given, determine A, B, and C, and mark on the graph. Okay, that's all right. Sketch the ellipse, determine the direction, horizontal or vertical. I think I'd be determining the direction, horizontal and vertical before I sketched it. But, you know, these are the things we got to do. Does that make sense? Okay. So, on this, remember, there are properties that we just learned. Find the standard form of the equation for the ellipse whose major axis has endpoints -2, -1, and 8, -1. Okay? Well, you know, if that's the endpoints of the major axis, half that distance is my semi-major value, okay, my A. So there's a couple ways to do it, and I could put it in the equation, but since I have a graph, I'm just going to count, okay? So I got -2, -1, and I got 8, 1, 2, 3, 4, 5, 6, 7, 8, -1. They are 10 apart, okay? So my major axis, my semi-major, is 5. Does that make sense that A is 5 from that? A is equal to 5. You could go, hey, well, you know, I got -2 minus 8 squared. And then I got -1 minus -1 squared. And find out that, hey, that square root is just going to be 5. I'm not going to do that to you. Distance formula, okay, we just counted on the graph, but I suppose I just did it myself. They told me that was the semi-major, right? So I know A is with X. Does that make sense so far? Now, they tell me also that the minor axis has a length of 8. Well, the semi-minor, therefore, is 4. Remember, semi-minor is B, so the minor axis itself is 2B, and if I already know that the minor axis has length 8, B is equal to 4. So now I have a standard formula because A is with X. I've got X squared, 5 squared, plus Y squared, 4 squared, equal 1. Does it make sense where everything is coming from except for one thing that I put in my HK? Just out of habit, I forgot it. Remember, it's X minus halfway through, 1, 2, 3, 4, 5. So my center, 1, 2, 3, 4, 5, is 3, -1. Okay, so I've got X minus 3, quantity squared, Y plus 1, quantity squared, as I step that through. Yes, sir?
Where'd you get 8 from? Like when you had 2 B's? Oh.
Yeah, my semi-minor axis had to be found, and that's just half the minor axis length complete. Okay. Now, remember, the minor axis is 8 length, and I go 4 up, 4 down from the center, and I have the endpoints, and I'm going to go through everything. Oh, that was really bad. The beauty of this, maybe, might be able to squeeze it in. Okay, good. Phew, wiggled it in. Okay. But does it make sense what I found so far? I did not find the foci. They didn't ask me to. Okay, find the standard form of the equation for the ellipse whose major axis, and I suppose I should just to make sure that we know how I can do it. The foci would be a squared is equal to b squared plus c squared, where a being 5, b being 4, all of a sudden you see 3, don't you? Because it's the Pythagorean triple, I'm hoping. Okay, so c squared, that's going to be 9, so it's 3 squared is equal to c squared. So c is 3, so here is 1, 2, 3, 1, 2, 3. So I can talk about my foci as being my foci location. Remember, since I have 3 and it's with x, okay, a is with x, so the foci is plus or minus with the x side, and it was 3, so I've got my minus 3 and negative 1, and I got my plus 3 and negative 1. Okay, I know I could have totally read that from the graph, but I want to make sure you know how I do it with the HK. Okay, so that's going to be 0, negative 1, and 6, negative 1. Let's check to make sure I put them in the right spot. 0, negative 1, and 1, 2, 3, 4, 5, 6, negative 1. Okay, you all right with that? You feeling okay and comfy? Now, just like anything, we've done a few, we have a pretty good idea. Use the jargon as we go. There is a shortcut, you know, a little card to actually follow, you know, what's foci, you know, what's the semi-minor axis, semi-major axis, and I kind of put in there on the top with X, okay? Check out, see how you do number 4. Give it a try on your own at first. Give it a try on your own. Find the center, vertices, foci of the ellipse, okay? Give it a try. Turn it back on when you're done. Okay, as I go through, I'm going to kind of step through. If you might not be done, or you might be in the process of being done, you might have some questions. Make sure you ask, make sure you nail me if I make a mistake. But the first thing, keep in mind the center is going to be here, negative 2, 5. So I'm over here at negative 2, 1, 2, and positive 5. 1, 2, 3, 4, 5. And this graph, by the way, is going to be off the page, so don't be thinking, oh, I've done it wrong, because the graph's all just kind of skied out. Now, I can read my A, and I'm going to put it in the right order. And although I redo the order, my X and Y stay together with H, X plus H, Y, you know, X minus H and Y minus K. But here, I've got X plus 2 squared over 3 squared. So now I know that A is 7, which means my major axis is 14. I know that B is 3. That's a major axis of 6. I now can find C. I gotta find a better color. A squared is equal to B squared plus C squared, where I've got 7 squared is equal to 3 squared plus C squared, and that's 49 minus 9, so 40, square root of which is C, as we step. Okay. Now, are there any questions about the things I found? Keep in mind, A is with B. Or excuse me, A is with Y, not B. A is with Y. Good Lord, let's just say it and do it wrong both times. Okay, A is with Y as we go through. So I know it's a vertical axis, and it's going to go 7 up. 1, 2, 3, 4, 5, 6, 7. Up here at 12. So it's negative 2, 12. And it's going to go 7 down. 1, 2, 3, 4, 5, 6, 7. And it's going to be at negative 2, negative 2. So that's those are my vertices, and probably should just put them over here so you can quickly read them at negative 2, 12, and negative 2, negative 2. I've got my foci. I just found C. I got a plus or minus square root of 40. I'm not going to put it in the lowest terms. It's something that we can find. So my foci is with Y. And remember, my Y value from my center is 5. So I've got negative 2, 5 plus or minus the square root of 40. And keep in mind what the square root of 40 is. It's a little more than 6, right? Between 6 and 7. So I'm going to go for my center, 1, 2, 3, 4, 5, 6, and a little bit more, and 1, 2, 3, 4, 5, 6, and a little bit more. So I got my foci in there for C. And now I've got my minor axis information, and I'm 3 on each side, and I used red on that. So it's 1, 2, 3, 1, 2, 3, and I can get my ellipse sketched in there as I go.
So if you're a major axis, why are you calling it minor axis then?
Well, the major, I should say, thank you. It's my other M word. Some people have typos, I have rightos. Okay, thanks for pulling that on me. Okay, but we've got a minor axis, which is B. Our B is our minor axis, and I'm sorry I listed it that way. Okay. Are we all right with where's it going? And how everything fits together? And the transformation isn't that bad if you keep in mind what H and K is and how the effects of the major, minor, and foci have when the A value, the largest value is with X, and the A value is the largest value is with Y. Okay, if you can keep those up. We're going to complete the square practice. I want to make sure you guys see that. So this one is, we're going to be completing the square again tomorrow, as promised. And I just want to make sure we practice when we don't have just a 1 in the x squared area. So I want you to see it, and I want you to practice one. But here's the deal. If I'm going to complete the square here to find my answer, remember that's the same as putting it in and finding the quadratic formula. Okay, it's another possibility I can do. I got to first factor out the 9. So I have this situation. I don't care what happens on the other side. I must have a 1 in position right next to my x squared. The coefficient of x squared must be 1. Okay? Otherwise, whatever I do is just going to be a bunch of junk. All right? Now, after I do that, I take half of my b value, half of 4, and some people, you must take half of negative 4. Dude, if you take half of whatever it is with a sign and you square it, it's going to be positive. So I just look at it as half of 4. 2 squared, that's 4. Okay, but I added 4 here, right? But keep in mind, what's on the front side here? It's a 9, right? If I distributed the 9, wouldn't it be adding 36? So to make sure that the addition didn't change the value of this, I'm going to add 36 over here. Questions about why I did it? It's very similar to what we're going to be asked to do tomorrow. Because of that distributive property, I just didn't add 4, I added 36. Okay? Now, when I get this rolling, I can then look at this as I've got 9, I've got x minus 2, quantity squared, equal 57. Sorry, I might look a little surprised, but it was close. Okay, so I've got x minus 2. If I take the square root, I'm not going to go crazy. I got 57 ninths. Okay, it's almost 63, but it's not there. I'm going to take the square root of both sides. Okay, I add 2, but this is a plus or minus. So I've got 2 plus or minus the square root of 57 divided by 3. Okay, and that's how I would go ahead and find my answer. But really, we're looking at completing the square, and we're going to be at this point tomorrow to just talk about how we can set up our standard ellipse equation, okay, when it's all been multiplied out. Okay, that's what we're going to be doing. We'll start tomorrow with this one before we get to that perfect square stuff. Okay, thanks for your time today, guys.